Hello, my name is Werner Altewieser, and today I want to talk about effective dependency management for iOS applications with our custom fork of Carthage. So what's my background? I worked as a freelance iOS developer since 2008, when the original App Store came live. Within the period, I also did my own startup and I worked for several companies, ranging from very small to very big. And I created over 10 different applications, some of which were very large scale and included a lot of dependencies. For dependency management, I worked with different methods of dependency management, including Git submodules, CocoaPods, Carthage and Swift Package Manager. So I have quite some experience within the scope. So what are the requirements for efficiently working with dependencies? In my point of view, you don't want to wait for rebuilding of dependencies unless it's strictly necessary. In particular with Swift, rebuilding happens a lot of the time if you just include the source code. Xcode is not very smart to just build the source files that actually changed. And when is a rebuild really necessary? That's only when the Swift toolchain version changed, or any source file changed, or the version changed of a dependency. Second of all, working with binary dependencies is fine, but you still want to be able to debug into the source code. It's very easy that way to find bugs, maybe in dependencies or what happens exactly. Having a black box is very hard sometimes. Then you should be able to use remote binary dependencies to avoid rebuilding on a local machine and or your continuous integration servers. It should be able to use a centralized local dependency cache to avoid rebuilding for a project if you already built the same dependency for a different project. Then it should also be possible, if you made local changes to the source code of a dependency, for example to just add some debugging statements or print statements, that will automatically pick that up and will rebuild the dependency as needed. Then it also needs to be able to do concurrent builds without running into issues. It's very important for the continuous integration servers. So let's talk a little bit about which iOS dependency managers are present and their pros and cons. So first and foremost, and probably the most popular, is CocoaPods, which I've used very extensively. Then Swift Package Manager, which will probably be the standard in the very near future, at least for Swift source code. And last but not least, there's Carthage, which has a different philosophy to dependency management from CocoaPods, but has its own use cases. So what is CocoaPods? It's very invasive to your project. So for some it may not be a problem, but for some it is. It will modify the Xcode project file, and if you work with many developers, you can quickly run into issues with merge conflicts in the Xcode project file, especially when not everybody has the same version of CocoaPods. Then it includes dependencies by source code, so it requires a rebuild of all your dependencies as they are built every time. Binary dependencies are not possible, unless you include a custom plugin, which has also disadvantages, because with a custom binary plugin you lose debugging. And also it's only local to the current workspace, so on a CI server it would still have to rebuild every time. Then Swift Package Manager. So the first and foremost disadvantage of Swift Package Manager is that you cannot have different languages in the same target. So you cannot mix Swift and Objective-C source code in the same target, which for a lot of dependencies we have in our current company is very much of a requirement. Then there's no real way to specify binary caching for building, so you would have to rebuild the source code every time. And also it's not possible to include pure binary dependencies without having the source code. Then Carthage, the original version of Carthage. The philosophy of the original Carthage is to let the integration be left to the developer instead of trying to do it for you. So it has support for binary dependencies and also source code dependencies, but if you use pure binary dependencies, it only works through a JSON file that you would serve on some unprotected HTTP server, which within a corporate environment is not always feasible. Then there's remote binary caching, but that's only available for GitHub dependencies. Again, within a corporate environment, it's probably not feasible to do that. Then the binary caching does not take the Swift version into account. So there's only possibility to have one pre-built binary and not one for every Swift version, which until we have module stability in Swift, which will probably come in Swift version 6, is very much of an issue. Then there's no centralized local binary caching. It will cache binaries downloaded, but it will not cache binaries that are built on some location of on your machine, so they can be reused by a different project without having to rebuild. Then there's no debugging possibles with binaries that were built on a different location, because the debug symbols will contain absolute paths to the original build location, so you won't be able to step into the source code. Then there's concurrency issues. If you run it on the CI and you run more than one Carthage job at the same time, it will quickly fail because it doesn't lock the git checkout directories or the build directories or any other directory that it uses. It has resolver issues, which is very much of an issue if you have large dependency trees and also sometimes invalid dependency trees. It will quickly spin up to 600% CPU or more and recurs into an endless loop. Then there's also issues with pinned git references resulting in some invalid dependency trees, which we noticed in our current projects. Then the integration is kind of tedious because it requires every framework which is in Carthage build to be manually supplied to a copy frameworks task in your project. And then there's no limit to the scheme Carthage will take into account when building, sometimes resulting in too many schemes to be built and resulting in duplicate or unneeded binaries and waste of time basically. So we wanted to use Carthage because it suits some of our requirements, but there are a lot of issues with it. So we tried to set out and solve some of those issues. So why did we create a fork? Why not pull requests in the original Carthage? So I started out doing that. I tried with an improved resolver and to get it merged in the original Carthage. I also created a pull request for creating test cases for the resolver. But it took over a year and it was still not merged. And there was endless discussions on architectural and semantic details. Then in my opinion, the code base required a very big refactor to be able to fix some underlying issues like the concurrency and the testability. And then the rate of progress, if you look at the new features being introduced, is very, very slow. So because so many people work at it and nobody takes real ownership, it's almost impossible to get something in there. That's basically what I noticed. So that's why we set out and created a fork. We really needed this functionality. So we created this fork in GitHub under the NSOperations group. It fixes all the issues in the original Carthage for our requirements, which I will show in some demos. The README on GitHub describes all the new features and all the bugs we fixed. So I want to talk a little bit more about the Carthage caching, especially what we made available in our fork. So there's 3 levels of caching. The first is remote binary store. So that could be any kind of binary store, like Artifactory, GitHub releases, Bintray, an FTP server, maybe even another server where you use secure copy, or just some file share. Then there's a local binary store, which is in your local library caches directory. It contains binaries that were built or downloaded, and they are separated by Swift version and build configuration, like debug or release. Then within each project there's the local project cache, which is in Carthage build. If there's no change to the source code or to your dependency version, it won't even need to revert to any of the higher caching mechanisms. So first let me present a demo where I will show that the concurrent building is now possible. And I will show that the Carthage is able to do concurrent checkouts and concurrent building for projects on the same machine. So let me create a sample project. And I create a card file in there, which contains the Carthage dependencies. I will use some very popular open source dependencies. Let's save the file. And then I will copy this to another directory. Now we'll trigger the same Carthage command on both these folders at the same time. So I will show you which Carthage version I'm running, which is our Carthage NSOperations fork 0.37.1. And I'm going to do a Carthage update, specifying the platform iOS and configuration debug. And I will run this here as well. And I will run it at the same time. So the original Carthage would quickly run into problems now because it's using the same directories. Here you see that it displays as waiting for a lock on a Lemofire 482 to be built because the other Carthage is already building it. It will not only do this locking for building, it will also do it for cloning or for any other operation which involves the same directory for different processes. You are able to specify a lock timeout to the process, which by default is infinite, but the build could fail within a certain period of time if you want to. Even if the process would crash, it would still clean up the locks because it uses the system utility shlock, which will take care of that for you. Okay, that was demo 1. For my second demo, I will show that you can use binary dependencies with our Carthage fork while still maintaining debug support, so you can step into the source code. And that works even if you make local changes to the source code of that dependency. Let's start by creating a sample project, including some dependencies. I will use a single view iOS application for it. We'll name it sample. Put it in its folder. We'll copy the card file we previously had to it. Then I will go into the directory and first build the dependencies. Update, configuration debug, platform iOS. You see that it didn't need to rebuild the dependencies because it found them in the local binary cache already. Okay, now I'm going to add the dependencies to the project. Sorry, I'm first going to create a workspace. That's better for maintainability. So we'll create a workspace where we'll add the dependencies and the project itself to it. We call it sample XE workspace. We add the project to it. Now we've got a workspace with one single project in it. Additionally, I'm going to add the dependencies to it. We need the source code to be able to debug it. It needs to be present in a workspace. So I'm going to add a LamelFire Xcode project to it. I'm going to add a LamelFire image.xcode project to it. Okay. Now what we could do is just link these dependencies, like so. But what this will do is that it will always rebuild the dependencies. You do have the possibility to step into the source code, but it will always rebuild them. That might not be such an issue with only these two dependencies, but if you have very big dependency trees with a lot of source code, that will be an issue. It will take a lot of time to rebuild everything. I will show you what happens. I just add some piece of code that uses the dependencies, the view controller. So let me copy paste some code. Just going to use a LamelFire to load some data. LamelFire. So it's building a project, running it, and then it reaches my code and I'm able to step into it, which is all fine. The disadvantage though is that you will see that it rebuilds everything every time. This is obviously not what I want. So let's choose a different path. Instead of having these dependencies in here, I will specify the pre-built binaries which were built by Carthage. So those reside in Carthage built iOS, LamelFire image. Now Carthage requires also a copy frameworks build, run script build phase, which will embed also the debug symbols. This can all be read in the README of the original Carthage as well. Now, with the original version of Carthage, you would have to specify all the input files and output files. The output files would be the destination where they are copied, so it can compare the dates, the timestamps, so it won't recopy them every time. And you would have to list all the files in here. But in our fork, we have made this easier by specifying the auto flag, which will automatically discover the linked binaries which are in the Carthage folder. So this is sufficient. This is only once that you need to do this. If you add frameworks via Carthage, it can remain the same. So now let's clean the build folder, run our code again. We'll show you what happens. So you are able to step into. But if you look at the build log, what happened is that it still rebuilds the LamelFire. And why is that? That's because by default Xcode uses a flag called find implicit dependencies. And what that does is that it will automatically try to discover all the dependencies it needs to build. And you need to turn it off. So when you do this, you build again. So now if you step into, it will still work, but if you look at the build log, surprise, surprise, you see that the LAML file is not rebuilt, which is what we want. The only thing is, I also want to be able to make local modifications. So say we would like to add a print statement to this code, just to be able to debug something. If we run, obviously the dependency will not be rebuilt because we have nothing in place for that. So you won't see the print statement. So for that, I'm going to add a custom run script build phase. Or better, a target, which contains this run script build phase. So I'm going to add an aggregate target. We'll call it prepare dependencies. And then we'll add a run script phase to it. And that run script phase will perform a Carthage command, which will build dependencies as needed. I will copy paste the command. So what this does is, first of all, if Carthage is already running, it won't recurse into this prepare dependencies run script because it calls Carthage again. So this may not be very relevant for an end project like this one, but it is relevant if you do this in a framework, which may be built with Carthage itself. So it will exit just and not do anything if that's the case. Then it will clear the environment and only pass the developer dir and path to Carthage. That's to circumvent some issues with that. And then it will call Carthage build with a configuration specified by Xcode, platform iOS, and the options cache builds and track local changes. The latter option is there, it's only in our fork, and is there to calculate a hash on the source code. If that hash changes, it will rebuild the dependency. Now let's see how this works. So first of all, I have to create a dependency on this run script, like this. So it will be called every time when we run the project. And then when I run it, you will see that the dependency is rebuilt. Why? Because we made a local change to it. It will try to install the binary from the local cache, but it sees that the source code has changed, so it will rebuild it. Of course, this takes some time because that's to rebuild the dependencies, but if you don't make any additional changes, it doesn't have to rebuild again. It will only rebuild if you make changes to the source code. Okay. I have to clear the build folder because it still has a reference to the old dependencies. Which happens sometimes. That's just an extra thing. Now you see the print statement. Right? So I was able to make a local change and still step into it. Now if I don't do anything, if I just rebuild and rerun, you will see that the dependency is not rebuilt. You still have the same change. And now if I undo the change again, stop and rebuild, you will see it will rebuild the dependency again. So there's no print statement anymore. So basically this concludes our demo, and it showed us how we can both rely on binary dependencies for speed, while still maintaining the flexibility to step into the source code and even being able to modify it. So there are two more demos I'd like to present, but I will do those in subsequent videos. And the first demo is about showing that binary dependencies can be pulled from custom binary stores, like Artifactory or a file share or whatever. And the fourth demo is about showing that you can work with binary-only dependencies. And that could be handy, for example, if you have images which you want to version, for example for snapshot testing, or just for assets within your app, or other binary frameworks for which you may not have the source code. So I'm going to present those two demos in subsequent videos. So that's all for now. Please check out the Carthage NSOperations fork, and be sure to share any issues you have with it. I'm actively maintaining it and fixing bugs in it. So that's all for now. Thank you.